Hello, welcome to this lecture on computer integrated drafting and geometric modeling. Myself, Lovepreet Singh, Assistant Professor, School of Mechanical Engineering, Calcutta University. I welcome all of you with this course, that is BTME3009, CAM and Automation. In the today's lecture, we will discuss about the computer aided drafting and the geometric modeling. Uh, In the today's lecture, the learning outcomes are concept of computer-aided drafting, types of geometric modeling representation schemes, desirable features of geometric modeling softwares. So the computer-aided drafting, a drafting system operates only in two dimensions. A computer-aided drafting system is employed to set vectors such as units, drawing limits, grids, and layers. Factor to be considered while determining the limits of drawing area are actual size of drawing, space needed for dimensions, notes, bill of material and other details, space between different views so that drawing does not look cluttered, space for borders and their block, layers in drawing. The drawing task for many layers is much easier than handling one complicated drawing that contain all the entities. Layering allows overlapping layers without increasing the complexity of drawing. The layer function can also be conveniently used to generate the component drawing for an assembly. As you can see in this diagram, there is a layer and display over the drawing sheets. These are the drawings with the different layers, and here the illustration of three layers on layer 0, layer 1, 2 and 3 in the drawing. Grid and snip. Grids is a network of uniformly spaced points overlapped in screen. There are two kinds of grids. One is a rectangular grid, other is radial grid. The grids are useful for sketching, placing text at specific locations, clicking the free hand to indicate geometric locations. These are geometric locations. The location of a point may not be exact due to unstable motion of human hand. To avoid this problem, set the cursor to snip the nearest intersection point of the grid line. This feature is called the snipping. Drafting system. There are many drafting software packages available for two-dimensional applications such as AutoCAD, DraftSight, Rhino, and others. There are four stages in drawing with AutoCAD. One is planning, drawing, modification, demonstration. So this is the user interface for CAD 2004, as you can see in this screenshot. Geometric modeling. The geometric modeling is a computer compatible mathematical description of geometry of an object. The geometric modeling is the most important aspect of any CAD/CAM software. The main application of geometric modelings are assembly design to assemble the sub-assemblies to generation of virtual products, kinematic analysis for understanding the motion of assembly models, generation of numeric control part programming. Geometric model is used as reference model for inspection process. Types of geometric modeling. The graphical geometries can be categorized into three basic forms. The two-dimensional models, 2.5D models, 3D models. The three different forms of 3D geometric modeling representation are wireframe modeling. It's a wireframe modeling. This is surface modeling, and this is a solid modeling. Forms of 3D geometric modeling approach. Wireframe models create solids by using basic entities with their attributes such as lines, curves connected properly with vertices. In the surface modeling, the surfaces are created by connecting lines so as to generate the external shape of solid. The surfaces are created by analytical methods or with synthetic surfaces. As you can see, this is analytical method, this is synthetic services. In the solid modeling, the solid model is created directly from the basic 3D building blocks known as primitives. This is already discussed in the last slide also. Parametric and feature-based modeling. The parametric nature is the ability to use the standard properties or parameters in a defining the shape and size of geometry. One can change the shape and size of any stage at a design process. Feature-based model employ the concept that a solid contains the different features such as holes, pockets, slots, chamfers, ribs, and so on the parent features. So feature-based modeling like fillet is the feature-based modeling, and hole that is also a feature-based modeling. The main advantage of solid models can be used to compute the mass properties such as mass centers, moment of inertia of complex object due to mathematical description of internal shape. Solid model can be used to check interface between assembled components and apply collision avoidance tools. Assembly modeling. The assembly design has two or more components assembled together at their respective work position by using parametric relations. So assembly, this is assembly view, this is exploded view. The features of assembly model system are as follows. It create a parametric constraint relationship between parts, a complete change in propagated along the assemblies, and constraint capture design intent, including the common dimension of parts, position of parts with respect to each other, alignment of parts, joint condition, mating condition, and operational parameters. The features of solid modelings are there are two types of assemblies. Fully defined assemblies in which all the relative movement of all components is constrained. Assemblies where the components are not fully defined and some degree of freedom are kept constrained. So this is a two-part phases, and after assembly of the two-part phases, when all the phases are fully defined, so it cannot move here and there. Modern trends in solid modeling, the use of intelligent computing techniques in CAD for optimizing and design has drastically improved the accuracy in attaining the solutions. Direct modeling allows the use of intensive, selected and manipulated geometric and entities in real time, regardless of features history. The modeling system can be classified as explicit system and variable driven system. An explicit modeling system is a design built without capturing a relationship between entities. The variable driven modeling system are based on dynamic explicit geometry with the ability to the geometry to be altered using dimensions. Parametric and variational models. The parametric modeling deals with imposing geometric constraint or entering dimensional data instead of directly specifying the shape of object. The variational geometric modeling goes a step further, specify the constraint that a shape must be satisfied along the unknown parameters. Other models are adaptive modeling, dynamic model, feature-based modeling. Desirable characteristics of a geometric modeling package. Some common characteristics required for any geometric modeling package for CAD applications are: the package should have a user-friendly interface with effective visual characteristics such as zoom and several modeling options to generate the model quickly with minimum efforts. The package must facilitate editing and manipulating the existing models at any stage of product design. The model generation from package should have a capability to open in any analysis package module. Geometric modeling package must allow interchangeability or transferability. Modeling geometric should allow the generation of advanced drawing for the computer-aided drafting system for geometric modeling without several user inputs. So the graphic package is a software support between the user and graphic terminal. An example of a standard graphic package is a graphic kernel developed by International Standard Organization in 1982. The main function of graphic package are generation of graphic element, editing operations such as mirroring, zooming, and so on, graphic transformations, display control and windowing, segmenting functions. So generation of graphic element primitives, these are certain basic elements which are displayed on graphics library, including lines, polygon, and text. The basic 2D elements is called entities, while standard 3D elements are known as primitives. So there are certain basic elements which are displayed by graphic library, including line, polygon, and text. The basic 2D elements are called entities, which standard 3D elements are known as primitives. So, for example, if there is a line having coordinate 2, 3, and 4, 6, it can be denoted as 2, 3, 4, 6 in this form. Editing operations. A CAD system provides editable capabilities to make correction and adjustment in geometric modeling. Some common editing features are move an item to another location, duplicate an item, rotate an item, mirror an item, delete an item, remove an item, trim a line or other component, create a cell out of graphic element, scale an item. The transformation. The transformation are also called mapping from one coordinate frame to another. There are three basic transformation: translation, rotating, scaling. These are called Euclidean transformation. Here, the shape of a geometry entity will not change. The line remain in line or circle will remain in circle after transformation. So this is called Euclidean transformation. So development in CAD/CAM technologies, computer graphics and software technology have led to enormous development in CAD/CAM. The CAD tools may also be used for manipulation of graphics element, interface checking in assemblies, tolerance analysis, mass property calculations, finite element modeling, in development and analysis and optimization routine. So these are the application or development in the CAD/CAM technologies versus with time. So first is the manipulation of graphics element. Using the CAD software, we can manipulate or we can edit the graphic element as per our requirement. So interface checking in assemblies. Once we have drawn the CAD/CAM, the any part or any assembly on the CAD software, then using that software we can check the interference between two assemblies. Then there is tolerance analysis. We can analyze the tolerance, what is tolerance, minimum tolerance required, what are the mass property calculations, what are the mass property calculation, what are the finite element modeling in the development of analysis and optimization routine. So these are the development. So there are three types of integration. First is data integration, second is interface integration, next is application integration. So in the uh, CAD system, there is a CAD system. This is CAD system. It's connected with database structure, and that database is connected with CAM system. So first is a CAD system, then which is two-way communication with database structure. Then database structure is connected further with the CAM system. So this is the integration of a any CAD/CAM system in with the each other. So next are the advantages of CAD and CAM systems. So integrated CAD/CAM system facilitate the following advantage. First is the increased productivity. Uh, Using the CAD/CAM integration, we can increase the productivity. So as the lead time becomes shorter, so the processing time will get shorter, so you can produce the more product using the CAD CAM system. The shorter lead time, reduced human resources intervention, as we are using the automated system for designing and manufacturing. So there is a reduced human resources requirement, improved accuracy of design. So accuracy of the design get improved, the easier recognition of component interaction during analysis. So this is the next good point. The better functional analysis to reduce the prototype testing, assistant in preparing documents and drawings, more standardization in design, improve productivity in the tool design, and fewer error in our part programming. So if the these are the advantages of CAD CAM systems in manufacturing. So next is the application of CAD CAM, industrial and architectural design, mechanical design, electrical electronic design, plant layout, marketing design. So these are the applications of CAD CAM. So these are the reference which you can refer for further studies. And thank you.